In our first lesson on solving linear equations, we talked about two things to keep in mind. The first was to isolate the variable, and then the second was whatever you do to one side of the equation, you must do the same thing to the other side. In this lesson, we're going to continue with another method of solving linear equations. Well, not necessarily another method, but a different variation. And in this lesson, you still want to keep in mind to isolate the variable and also to make sure that you do the same thing to both sides of the equation. Okay, having said that, let's go ahead and start with an example. So example 1, we have 2x plus 5 is equal to x plus 9. Okay, so in this example, what we want to do is combine like terms. What do I mean by that? This is a like term, 2x and x, right? They're similar because they have an x associated with it. And then the other like terms are 5 and 9. They are similar, 5 and 9, because they have no x's associated with them. They're just numbers, okay? So when you have that scenario happen, you're going to want to move like terms together. And in this example, what we're going to do is move this x over to the left side of the equation. And to do that, we have to subtract x from both sides. So we're going to subtract x here, and we're going to subtract x here. Okay, and when we do that, we get, and I'm not going to do any computation yet, I'm just going to write everything out. We get 2x minus x plus 5 is equal to 9. Okay, the x's cancel out on the right side of the equation, and that's the whole reason we subtract x from both sides, because we want to eliminate the x on the right side of the equation and move it to the left. And if you notice and follow the negative x, okay, over here we've got a negative x, it just continues on. We haven't done anything here. So then the next step we want to do is compute this. So 2x minus an x, so 2x minus 1x becomes just 1x or just an x, okay? And we're going to continue to write everything out. And now we have x plus 5 is equal to 9. So now we're going to move the 5 over to the other side of the equation. And to do that, we have to subtract 5 from both sides. Subtract 5, and we're going to subtract 5. Okay? So once we do that, we're left with x. This 5 and the negative 5 cancel each other out. We have equals 9 minus 5. And then we're going to finish the computation and get x is equal to 4. Okay, and that is our answer to example 1. Okay, so let's move on to example 2. Okay, so in this example, we have 5 terms. We have a negative 3x, a negative 9, an x, a 5x, and a negative 2. Okay, so same thing like example 1, we're going to want to combine like terms. So first we need to identify where the like terms are. Okay, so the first like term is right here. Negative 3x, an x, and a 5x. Okay, those are like terms because they all have something to do with an x. And then the other like terms are negative 9 and negative 2. Okay, so those will be our focus. So the first thing we want to do, and there are actually a few different ways to approach this. The simplest way is to combine negative 3x and x together first, right? Because we have 5 terms. We have 1, 2, 3, 4, 5. And there's a lot of pieces to deal with. So we want to simplify as much as we can before we start moving things around. So we're going to combine negative 3x and x together. and we're going to get negative 2x. Okay, negative 3x plus x is negative 2x, and then we're going to just write everything else out. Minus 9 is equal to 5x minus 2. Okay, now it gets a little easier because now we're just dealing with 4 terms. 1, 2, 3, 4. So again, we still want to combine terms, but what makes it a little bit awkward is that we have a negative here and we have a positive here. Okay, these two terms are what we want to put together. So I'm going to do something that's probably a little bit contrary to what you may think, but once I get through it, you'll understand why I'm doing this. Okay, so what I'm going to do is I'm going to move this 2x over to the right side. Normally we move everything over to the left side because we like to have the variable like this over here in example 1 on the left side. But because of this negative, I'm going to move this over to the right side. Okay, so this is a negative 2x. So to get rid of that, we're going to need to add 2x to both sides. So we're going to add 2x, and we're going to add 2x here. Okay, so when we do that, these cancel out, okay, and we're left with a negative 9. Okay, this is where a lot of you will make a mistake if you're not careful. What do I mean by this? See this negative 9? This is still a negative 9. Okay, don't just bring this down to a positive 9. You got to make sure that the negative carries through. You can't just ignore that. Okay, so negative 9 now is equal to 5x. I'm going to just continue writing this out. Plus 2x minus 2. Okay, no computation. All I've done is just eliminated the negative 2x. So now that we have this, we can now combine the 5x and 2x and get negative 9 is equal to 7x minus 2. Okay, 7x minus 2. Now what we want to do is combine the other like term, the negative 9 and the negative 2. And to do that, we have to move this negative 2 over to the other side of the equation. And in order to do that, we have to add 2 to both sides. Okay, so when we do that, we get negative 9 plus 2 is equal to 7x. And these cancel out. Okay, so now things are getting a little bit simpler. We now have negative 9 plus 2 over here on the left side of the equation, and we can combine that. Negative 9 plus 2 becomes negative 7. So we get negative 7 is equal to 7x. Okay, now remember earlier I said I was doing things a little bit backwards. So what happens here, or what happened here, is that the x is on the right side of the equation. With an equal sign, we can now flip things around. Okay, what I mean by that is we can just rewrite this to be 7x is equal to negative 7. Okay, do you guys see that? Instead of this being on the right side, it's now on the left side, and this, instead of being on the left side, it is now on the right side. The equality still is the same. It persists. Nothing has changed. I'm just flipping it around. It's kind of like a mirror image. Okay, so now we can solve for x. And since I ran out of space, we're going to go on to the next page and just rewrite everything. It was 7x is equal to negative 7. Okay, so that's what we had. So in order to isolate my x here, okay, we need to do something with the 7. And if you recall from the previous lesson, to do that we need to multiply both sides by the reciprocal. And when we do that, we make the coefficient in front of x equal to 1. That's the whole purpose of multiplying by the reciprocal. Okay, so what do I mean by that? When we have, let's go back to the previous page. When we have x by itself, remember what's implied is that there's a coefficient of 1 in front of the x, and that's ultimately what we want to get to. So in this problem, if we want x to be by itself, we want the number before it to be 1. Okay, so then to do that, we're going to need to multiply both sides by 1/7. It's multiplying by 1/7 or dividing by 7. It's the same thing. Okay, either way is fine. So when you do that, then these cancel out, and now you have just 1x or just 1. I'm sorry, just x. Okay, there's a 1 in front of the x. It's just implied, so we don't need to write it. So it's now just an x is equal to -7 over 7. Okay, I didn't do any multiplication. I just multiplied, or I'm sorry, I didn't do anything other than just multiply that together. So now we know that -7 over 7 is equal to -1. So x is equal to -1. And that is our answer. Okay, so hopefully that made sense. Remember, in this lesson, what we're doing is combining like terms. In addition to isolating x, as well as making sure that whatever you do to one side of the equation, you do the same thing to the other. If any of this was confusing, please go back to the beginning of this recording and listen to it again. Thank you.